Next, let's take a look at the serial ports, CAN, and Modbus communication examples of our GUI application running on ChIP-C industrial PCs. I will run this demo app on two ChIP-C industrial PCs, one ChIP-C industrial Pi and one 10.1-inch ChIP-C AIO PX30 industrial PC. Then I will let them talk to each other with the above communication interfaces or protocols. Okay, let's first take a look at the RS-232 serial ports. Let's visit the page on each PC, then I will enable receiving on each PC. Okay, now I will let the Pi say something to PX30, and see PX30 has received this test information. Now I will press this button to let the Pi say a long sentence. There's a log saying this Pi has sent a message through RS-232, and we can see PX30 actually received it. Now let's clear these messages and let PX30 say something to the Pi. I will press each button twice. Okay, let's move to the Pi and see, here they are. The Pi has received all 4 messages from the PX30. So this is an example of RS-32 serial ports communication. The 120 ohm resistor already mounted on these two devices in the factory, and TX and RX are also switched by hardware. Let's take a look at the RS-45 serial ports. Let's go back to the home page on both devices and visit the RS-45 page. The page looks identical to the RS-232 page, except that they are using RS-45 for communication. Let's do the same test as we did before. First enable receiving, then send messages from the Pi to PX30. Okay, PX30 receives them. And let's send from the PX30 to the Pi. Okay, cool. This is it about serial ports. Now let's take a look at the CAN devices. Before you start, be sure to mount your 120 ohm resistors by yourself before testing CAN. They are not mounted in the factory. Like this. After that, we can proceed. Now let's enable CAN receiving on both devices. Let's send something from the Pi, like we send a Pi with CAN ID 123. If we send something violating the CAN protocol, then we can't send that. This message is too long and the other device cannot receive it. Let's clear the screen, and we can also input something like CAN ID 1 and message 128. Click send. See, we have received it on the PX30. This is 1 and through channel CAN 0 with the message 128. Okay, let's stop receiving and go back to the home page. So this is an example of CAN on ChIP-C industrial PC. Next, let's take a look at the Modbus protocol here. We will need the RS-45 serial ports to test Modbus. So before we start testing Modbus, we need to stop receiving messages from the RS-45 serial ports on both devices. Okay, now we have stopped them. Next, I will start a Modbus server on this PX30. Let's move to the Modbus server page and Modbus client page on the Pi. Let's enable a serial Modbus server. Then I will use this ChIP-C Pi as a Modbus client. I'll press this button and it will run multiple Modbus tests like writing and reading to a coil or multiple coils. We can also see this Modbus server has received multiple commands on this PX30. So that's it for Modbus over serial ports. Next, let's take a look at the TCP Modbus. For TCP Modbus, I will start a Modbus server and a client on the same ChIP-C industrial Pi. Let's first go to the Modbus server page. I will enable a TCP Modbus server, and this ChIP-C Pi will start a Modbus server on port 5020. Then let's go to the Modbus client. Now I will click this test button and it will run the tests like we did on serial Modbus, but this time the commands are transmitted through TCP, like writing and reading coils or registers. So that's it for Modbus on ChIP-C industrial PC.